Yo, comms check. This is Roche Orbital, broadcasting to you from the asteroid belt in between Mars and Jupiter. The asteroid belt is a large asteroid field that orbits our sun. Unfortunately, it isn't like Star Wars out here. Our station isn't bobbing and weaving through tightly packed asteroids flying in all directions. Objects in space are much farther apart than we usually think. But these asteroids are relatively clumped together on the grand scale of the cosmos. Asteroids collide with Earth all the time, but luckily, most of these are small and they burn up in the upper atmosphere. The chance of a large asteroid contacting Earth's surface is very low, but it's not zero. This is why I was so excited to see NASA taking action with their DART program. Today, I'd like to tell you guys about DART, and I hope we never have to use it. But some things are hard to predict in our universe, so better to plan ahead. You feel me? DART stands for Double Asteroid Redirection Test. Two asteroids that are referred to are Dimorphos and Didymos. The largest of the two is Didymos, and in terms of size, its diameter is close to 2,500 feet. Dimorphos is much smaller, at 560 feet in diameter, and it orbits Didymos. Didymos orbits the Sun and is categorized as a near-Earth asteroid. DART's goal was to send a small spacecraft flying into Dimorphos at a very high speed, in an attempt to alter its orbit ever so slightly. The base of the idea being, if an asteroid was hurtling towards Earth and we nudged its trajectory, by the time it approaches Earth, that little change in its transit will eventually develop into a new path that will no longer collide with us. The person who got DART in motion was Andy Chang, a planetary scientist who worked at JHUAPL, short for Johns Hopkins University Applied Physics Laboratory. Teams of scientists and engineers from all over the world also got involved. His original idea was born in 2011. Fast forwarding to November 23, 2021, and the DART spacecraft launched into space with the help of a SpaceX Falcon 9 rocket. DART had a big mission ahead of it. A lot of planning went into the program, with multiple alternate procedures in case things went wrong en route. In fact, DART didn't go out alone. It was accompanied by a small cube satellite that was only 30 pounds. This little companion was made by the Italian Space Agency, and its purpose was to take before and after photos of Dimorphos during the mission. September 26, 2022 was a big day for DART, as this was its last day of the mission. DART impacted Dimorphos going around 14,000 miles per hour at 7:14 p.m. Eastern Standard Time in the United States. The Italian CubeSat got within 34 miles of Dimorphos after DART's collision to take photos of the impact, where it captured a large plume of dust rising into the surrounding medium. The James Webb Telescope, Hubble Telescope, and the Lucy spacecraft also tuned in to witness DART's final hour. After the first stage of the mission was a success, over 30 telescopes around the world monitored Didymos and Dimorphos to record any changes in speed or orbit. After some time passed, NASA announced that DART's impact shortened Dimorphos' 12-hour orbit by 32 minutes. Now, I get it. This doesn't seem like a lot, but for us as humans, being able to change the movement of a stellar body with our collective knowledge and engineering is nothing short of incredible. Nothing in our history has ever been done in this field. This type of mission has always existed in the realm of sci-fi. A secondary observation mission was also planned, called Hera. This mission is led by the European Space Agency, or ESA. ESA launched Hera on October 7, 2024, aboard a SpaceX Falcon 9 rocket. Hera's mission is to better understand the full effects of DART's impact on Dimorphos. The spacecraft will record data on the crater left by DART and study the asteroid's full interior composition. ESA hopes to calculate the energy transfer from the kinetic impact of DART. With this information, they could apply it to any new missions in the planning phases. Like DART, Hera will be accompanied by two CubeSats as well, called Milani and Juventus. These little companions will be deployed when Hera reaches Dimorphos, and their mission is to study every part of the binary asteroid system. Hera is scheduled to reach Didymos in late 2026, and I am super stoked to see what it uncovers. On behalf of everyone here on Roche Orbital, I'd like to thank you all for watching today. I'd also like to extend a thanks to all the amazing people who worked on the DARP and the Hera programs. This is truly a moment in history for mankind, and it gives me hope when humans come together to accomplish a goal. People from different backgrounds, different languages and cultures, dropping the borders of countries, embodying the human spirit, and seeing what we can accomplish when we work together. Just for a moment, imagine your life as an integral part of the universe. This is called a cosmic perspective. To grasp how small you are in this grand play we call our universe is important. Although we may be small, we are all connected to one another, and we are all connected to the cosmos around us. Hopefully, one day, we'll stop seeing other people as just them and see everybody as one. This is Roche Orbital, signing out.